Now, when I say aliens, I don't mean those green, photosynthesizing humanoid figures that we all picture. In fact, I don't really know what I mean.
Well, that's absolutely outrageous. How are you trying to make an informative video about something you don't even understand?
While scientists haven't found aliens yet, we're doing a few things to look for them. This includes searching for exoplanets and observing the atmospheres of those exoplanets.
Step 1. Find the exoplanets.
So, how do we find these exoplanets and what even are they? There are around 5 methods that we use to discover exoplanets, which are just planets outside of our solar system. These include radial velocity, direct imaging, astrometry, gravitational microlensing, and transits. Transits are usually used because you can extrapolate a lot of data from them, so let's do that. A transit occurs when a planet passes in front of its star, and this dims the light of the star. Scientists usually need 3 transits to occur before we can call something an exoplanet. The radius of the exoplanet is just the radius of the star over the radius of our Sun times by square root the depth of the transit. A secondary eclipse occurs when a planet passes behind its star. How much an exoplanet dims its star and the ratio between TT and TF can give us interesting things like the distance of the center of the star to the planet. By golly, that was a lot of information just from the dimming of a star. Whoever figured that out must have been bright. Okay, so we found the exoplanet, but how do we know if it has life?
Step 2. Find the life.
Time to get technical, or should I say, spectral. When we're looking at exoplanets' atmospheres for life, we want to look for biosigns, such as oxygen, methane, or carbon dioxide, such as the ones on Earth proving that life may exist there. To do this, we use spectrometers. Spectrometers work by analyzing the emission, scattering, or absorption of different electromagnetic waves using the release of photons. We use spectrometers to collimate and then diffract the transmitted light from a star that has passed through the atmosphere of an exoplanet using a diffraction grating. A photodiode detector analyzes the absorption light on the spectra, showing the black lines, thus we can see what the molecule has absorbed, and we can discover the atmosphere of the exoplanet. Just as a company has a logo which everyone remembers them by, an atom or molecule have an absorption spectrum in which everyone can identify them with. This, for example, is the absorption spectrum of oxygen. The black lines represent what frequencies have been absorbed. This works because photons are released when an electron wants to go back to the original energy level it was before it absorbed the electromagnetic ray. These biosigns absorb in the infrared, thus the new James Webb Space Telescope is going to be looking for the near, mid, and far infrared ranges, and that's going to get us closer to seeing the composition of an atmosphere. This could suggest life. But just because we haven't found any aliens yet, doesn't mean we never will. So next time you're skygazing, look up to the stars and give it a wave. Maybe somebody's watching back. Thank you for listening.